Yes, you can. And I'll tell you in a minute. Hold on. All right, guys. Everybody, we're talking about number 2. So number 2 focuses on the idea of inverse. What does an inverse function do? Okay, I love it. I wasn't sure what exactly I would get. Inverse function, you could say it does the opposite of the original function, right? If the original function was add to, the inverse is subtract to, what you do. But fundamentally, what it does algebraically and graphically is it just switches the x and y, correct? So if I need to graph the inverse of a function that I have to graph up to begin with, can somebody give me one point that g goes through? Any point that g goes through? 2, 3. I love it. So what point will the inverse function go through? 3, 2. So just make pick some points. Give yourself at least 4 points that this function goes through. Turn them all around and then regraph what you just put down. You guys with me? That's how you do it. It's almost too easy to believe. Algebraically, how do you find the inverse? You switch the x and y, solve for y. Graphically, how do you find the inverse? You find all the x, y's, and you switch them. And you plot it back. It's the beautiful thing about inverse is switch the x and y and you're golden, almost always, no matter what you have. Does it make any sense? Do you guys remember what it should end up being symmetric to?
Y equals x.
Y equals x. There's going to be a mirror at y equals x. It's really, really, really kind of nifty. So just to do a real quick example, that's not the problem that you have to do for homework. So if I had a graph that looked like this, let's say this is f of x. I think I tried to do this yesterday and made a horrible attempt. Okay, so here, hold on, I don't know if you can see this. Okay, yes, okay. If I want to graph f inverse, what I do is I first make a table of values for f. So that would be, let's see, -1, -3. 0, 2, 2, 3, and 3, 4, it looks like, with my horrible drawing. If I then do f inverse, I just take every point I just did and I just flip them. You with me? Because that's what the inverse function. What is an inverse? If the function originally took 0 and made it 2, what should the opposite function do? It should take 2 and make it go back to 0. It should undo whatever f did. If I have a machine that wraps a present, what would the inverse machine do? Unwrap the damn thing. Okay, so whatever the original does, the inverse undoes it. That's almost too nice to believe. It's like, no, math can't make that much sense. It's not allowed. So now I just replot these things. So let's see, -3, -1, 2, 0, 3, 2, and 4, 3. So then it looks like this. Do you see how that mirrors at y equals x? Maybe. Does this sound familiar to anybody? You guys remember doing this? I always like this because has anybody ever heard of the Nazca lines? Down in Peru? It's sort of, whenever you do this, it sort of ends up looking a little bit like Nazca lines. There's some nice symmetry in the Nazca lines. Look those up sometime. Nazca. If you never heard of them, look them up sometime because it's really freaky. How did they do that? Who knows? Aliens. I've seen them. No. You guys all right? Anything else? Yeah, and then we'll come back to Mary. Riley. Yeah.
So with the same question. The negative
Let's see. What was it, number 2?
Yeah.
D. Oh yeah, okay. So, inverse, what's it do? The original function, inverse comes along, what's it do? Takes all the x's and y's, switches them. What's the domain in general? What's the domain? What's the definition of the domain of a function? All of the x values. Yes? And what's the range of a function?
Oh my god.
So if I know G's domain and range, don't I just switch them because that's exactly what an inverse function does? So whatever the domain of G is the range of G inverse. Whatever the range of G is the domain of G inverse. What's the range of G? Range is what again? What letter? Y. So what's the range of G? Have a little dude. See my little dude? Walk him along the y-axis. What's the first time he sees the function? -1. What's the last time he sees it?
Looks like a positive.
Yeah.
1.5.
Yeah, 1, 2, 3.5 maybe? Yeah. So the range of G is -1 to 3.5. So what is the domain of G inverse? Same thing. Because what's an inverse function do? Switches x and y's. So it switches domain and range. Yeah. Oh, I have to assume, because I have to assume it stops here. I wish to God they would just put a freaking circle there, right? To tell us it stops. I have to assume it stops there because otherwise it might do this. And then a question about range is mean because I don't know what it does. So I have to assume it stops there. Is that cool? I can only work with the information I've been given. And I'm only given that it goes to there. So that's where things begin. Okay.
Can you give us a quick example about number 3?
Did somebody have a question about this one? Yes. Sorry, Brandon.
That's okay.
Domain? Oh. So I have a little dude walking on the x-axis. The first time I see the function is at, where am I at? -2. And when's the last time I see the function? I'm walking along, I'm looking up and down. When's the last time I see the function? 2, 3, 4, at 4, right? So it's just the x values that have outputs. What's the lowest x value that has an output? -2. What's the highest x value that has an output? 4. So the domain is brackets, -2 comma 4. What's the bracket mean? Include, because a bracket looks like part of a letter I for include. Yes? And remember what open circle meant? Not include. And doesn't a parenthesis look like half of an open circle? It's like there's ways to remember this shit. That's crazy.
Mind-blowing.
It's mind-boggling.
Yeah.
All right, sorry. Who did I just skip?
Aaron.
Brandon.
Green.
What's up?
So can you give us a quick example of number 3? It's like something different, but
Does this function look familiar to anybody?
like I understand the
Does this look
formula,
familiar?
but I
That's
can't.
the X, it's an A instead of an X.
Yeah, it's an A instead of an X, but does it matter?
No.
It's the same function, right? Okay. So this, what, does anyone remember what this, they call it the difference quotient, but we know better. What is this? Slope, because it's y2 minus y1 over x2 minus x1, yes?
Yeah.
Mhm.
You guys with me?
Mhm.
What's this input? What's the input here? A plus h. What's the input here?
A.
A. Everybody with me? So x2 is a plus h, x1 is a, so a plus h minus a is h. That's why there's an h on the bottom. So you guys with me? So whenever you see this, the difference quotient, we know that means slope. Because it's just y2 minus y1 over x2, that's all it is. It's crazy. So I'm sorry, Brandon. So, oh, now you just throw this shit in there. Okay, can anyone tell me what f of a is? Because you need that for this, don't you? What's f of a? No, what's f of a? No, that's f of x. What's f of a? A squared minus 2a plus 3. I like it. What's f of a plus h? I don't know.
2x plus 3? Sorry, 2.
A plus h squared
Yeah, a plus h squared minus 2 times a plus h. Well, so you gotta shove an a plus h in, correct? You guys all know how functions work. I know you do. If this is f of x and I say, what's f of 7? What do you do? How do you figure out f of 7? How do you figure out f of 7? 7 squared. That's right. You should take a 7, and wherever you see an x, you put it there, right? What does this first part want me to figure out? F of a plus h. So what do? I take an a plus h, and wherever I see an x, I shove a plus h in there. You guys with me?
Yeah.
I'm gonna have a strange way of saying things. It's very technical. So let's just focus on that for a second. What was it? Yeah. So I got this. Just to start off nice, what would f of 2 be? Come back. Come back. Such advanced technology we have. What would f of 2 be? 4 minus 4. So it'll be 3. Thank you, whoever said 3. So how do I do f of a plus h? A plus h squared minus 2 times a plus h plus 3.
Oh, so you just plug it in there.
Yeah, what do I have to do with this? Is that this?
No.
No, you can tell from the way I asked that, but you should also just know it's not true. How do you square something? If I said square 17 by hand, what would you do? If I said do it by hand, they'll use a calculator. What would you do 17 squared? 17 times 17 is how you do any damn thing. What is a plus h? It's a number I don't know yet. How do I square it? I write it twice, and then I multiply it out. And when I do that, what do I have to do?
Distribute.
Yeah, I like what you just said. Repeated distribution, because FOIL is dumb, but it's okay. Repeated what do I have to distribute? The a and the h. I don't need first, outer, inner, last. That's bullshit. I just repeatedly distribute. You guys with me? Am I going to get a middle term? Yeah, so it's not just a squared plus h squared, right?
There's even more.
Huh?
There's even more work.
There's even more work. I like it. I thought you said xenomorph, and I'm like, okay.
Oh yeah, this is alien right here.
This is totally.
Really easy.
Okay. Yes. It's just the technical name for what you end up with when you write the slope for some function that's not a line. So, just to kind of review what we did yesterday. What's the slope between 2 points?
y2 minus y1 over x2 minus x1.
Now, if I say that x2 is a, let me just, x2 is a plus h, and x1 is a. You guys with me? And why did we remember why we did that yesterday? Because the whole idea was, if I wanted to slope at a, don't I go a little bit above it? Make a plus h? Because what's algebra need to figure out how to slope? How many points does it need? 2. And we're trying to figure out slope at 1 damn point, because we're all insane.
Oh yeah.
And algebra's like, whatever the hell you want. I let h go to what? 0. That's the next thing we're going to do with this. But right now, they didn't want us to do that yet. Okay. So if I am curious about a, but then I go a little bit further from a, because I need 2 points, what would y2 be? And I'm working with a function f of x, let's say. Well, what's the second input? What's x2? A plus h. So what's y2? F of a plus h. What's y1? F of a, because the first input's a, yeah. And on the bottom, I'm going to have the second input minus the first input. So don't I just get exactly what they got? These cancel, don't they?
Yeah.
So don't I just get this crazy dude? Yeah. So whenever you see this, they're going to call it the difference quotient. We know better. That's the slope. That's what that is. The slope of a function at a. Okay, maybe. Yeah, so many hands. What's happening? What's up? So who's got a question about this one? Yes.
So I mean, when we plug it all in, right? It's just we just like it would be a squared and h squared,
I like it.
including the 2 extra variables. Would it just be 2ah then?
So you figure out what this is.
Yeah.
Let me make sure you guys are on. This is the question here, right? This is what this problem wants from us. What do you want from the problem? It wants this. Did we figure out what f of a plus h is? Sort of, right? You can figure out what f of a plus h is, right? You distribute, you FOIL. Everybody with me? Whatever the hell you get, you're gonna get a bunch of stuff, you just shove it right there.
Okay.
What's f of a? Just put an a in, right? Do minus all of that stuff. You guys kind of with me? Yes?
We don't have to plug anything in for h on the bottom,
Nope, not yet. The next thing we're gonna do is let h go to 0. So let's do this. Okay, let's do this. Can you guys take a moment? Don't say anything if you've already done this. Can you go ahead and simplify this for me? We'll do this together if you work with me. Let's do it. If I see people not working, I'm not gonna do it. Do it at home. So just simplify this for me. Is there anybody here that was not here yesterday right now? Oh, have you been in touch with me?
You emailed me this one.
What's your name?
Alexis Cortez.
Oh! I think I just emailed you this morning. Okay. It's good to see you. So just see me after we can catch up. Oh, yeah, that's right. You did email me back, did you? Okay, I got a little okay here. Who else? Sorry.
I'll talk to you.
Okay, okay. Alright. So if you do this, so just to remind you guys, this is what they want from me. So I call what we're doing a constructionist approach. I'm gonna construct what this crazy ass question wants from me. This crazy ass question wants to have this. Okay, I don't know what that is. Let me take a minute, go construct it. So what are you guys getting for f of a plus h?
A squared plus AH plus HH.
Plus h squared plus 2AH.
Is that cool?
Not yet.
Oh. So if you do a plus h times a plus, oh, sorry, I got it right here. A squared plus h squared, but you get one two ahs. Is that cool?
Well, we still got more to do, don't we?
Totally.
Yeah.
I just want to make sure everybody's moving so far.
Okay.
That's what this is. Minus,
2A.
you do things in such interesting ways. So 2a minus 2h plus 3. Is that cool so far?
Yep.
Okay, so I'm going to take that whole thing, I'm going to shove it there eventually. What is f of a? That was nice. Yeah, a squared minus 2a plus 3. If f of x is x squared minus 2x plus 3, f of a is a squared minus 2a plus 3. It's just shove a different letter in there, right? X is not special.
Oh.
Or no more special than anybody else. It's like syndrome. Everybody's special. Didn't know it. So now, if I put f of a plus h there. So guys, go ahead and do this next part for me. Put that, I'm sorry, I lost my last piece to this. There it is. Put this here, because that's what that is, yes. And then put this there. You gotta be careful. This is minus this whole thing. So put parentheses around it when you put it in there, right? You gotta subtract the whole damn thing. One of the most common mistakes we make is dealing with negative stuff, right? Zeros and negatives, they always find a way to screw us over. So f of a plus h is all this business here. F of a is this. Then I can distribute the negative. I'm just going to kind of do that here. Is that cool? Does anything cancel?
Yeah.
You guys with me? I just distributed a negative.
A squared.
Yeah, the a squares cancel.
And the 2a.
2a.
You didn't include.
Where'd my 2a go?
It's gonna be
A squared plus 2a plus a squared. Oh, minus 2a. Yeah, not an h there. Go out. And then plus 3 minus 3.
There's a minus 2.
Oh, there is a minus 2h. If I would just see everything, that'd be amazing. So it's a squared plus 2h, and I just sort of lost that poor little guy.
Oh, I thought it was 2.
Well, the 2h cancels one.
2ah is still there.
Oh, 2h.
Alright, let me try this again. Hold on. Let me get myself in a form from the beginning. Okay. Alright, here we go. F of a plus h, we figured out was a squared plus 2ah plus h squared minus 2a minus 2h plus 3, right? So that's the one I lost a few terms on. F of a is like that. So now if I throw this all in, I'll get all this business minus this business. So I'm just going to change the signs. Minus that, minus a negative is plus, minus 3, all over h. Yes? Okay, so now let's do this again. Notice what cancels. Can anyone tell me something common? Everything that's canceling, what do they have in common?
The A.
Most of it.
Everything I just canceled, what's common?
They all have a
They all don't have an H. So what is that? So everything that's left, everything left alive has an H. So what can I do now? Can't I divide each
Factor
piece
out.
by H? Now the one thing you gotta be careful about, don't just kill an H once. This does not happen. I don't cancel those and then it's gone, because what's being divided by H? Each of these things. So they each lose an H. Is that
Oh,
cool?
so you took out an H from the bottom and the top, right?
Yeah, so if I want to do this on the top, I take an H out,
Right.
and on the bottom I got an H, so these die.
Right. Okay.
Or I just divide each piece by H, so they each lose an H.
So is that it? Are we good?
That's it, yeah.
Yeah.
For right now, that's it.
For now.
Now, the funny thing is, the next level would be we would let H go to 0. Do you guys remember why? What does that mean? If I let H go to 0, what does that mean conceptually? Finding the limit, but towards what end? What was the whole purpose of this?
Oh, the middle.
Find the slope at a point. So if the other point's input is a plus h, and the first point's a, and I let h go to 0, I am going to end up with 1 point. Can I let h actually be 0? What mathematical thing that we now know exists can we use that doesn't let it actually get to 0? Limit. So that's the importance of limits. They let us investigate weird ass places. Something weird happens, I'm going to use a freaking limit. Because then I can get stupid close, but not actually get there and blow the world up. Right? Yeah.
Real quick. Take a picture. Would it be? Sorry.
What's happening?
Would it be? Oh, look at
I've got it right here.
that. Yeah, do it. So would it be? Would it be for the first time term of a plus h, right?
Hey.
Wouldn't it be? Wouldn't it be a plus h squared?
Totally, and that's what this is. We had already done that work, so I wasn't going to redo it.
Yeah.
That's what we got. Alright. So that is going to be, let me give you a little preview. That's going to be huge. The whole difference quotient is going to be huge throughout a lot of chapter 2. And then we're going to make shortcuts, thank the gods, when we get to chapter 3. Because if I had to do the whole difference quotient for every function every damn time, we would all go more insane than we will anyway. So we're not going to do that. All right, we're gonna work with it because it's important, because it is the basic idea. It's just algebra taking one step further. And that's what I wish most students would understand about calculus, is that's really all it is. Now, I'm not trying to downplay how weird it can get, but it's built on algebra. That's all, right? Okay. So if you really are, well, we'll see. It's gonna go away eventually. I'm gonna make some shortcuts, but not right away. Anything else from homework stuff that I can confuse people on? Holy shit. I'm just gonna go this way. Yes.
Number 18?
Yeah, so what kind of function is this?
It's one of those factory sort of things.
It's not parametric, because I don't see like X and Y being controlled by some third background Illuminati. Right? Sorry. It's a joke just for myself. Do you also have a question about this?
We have to do number 18?
Yes, you did.
Every other odd.
Every third one.
Oh, third one. So
Yes, don't get too excited. Is there a plane taking off? That sounds like a plane. I didn't know we had a plane. Holy shit. That's where the budget went. Okay. Guys, so number 18, it's called a piecewise function, right? Not pennywise, things don't float. It's a piecewise function because it's a function defined in pieces. So when in physical reality would this be important? What if I shot a rocket? Don't you agree that there would be a trajectory I could model with a mathematical function if I shot a rocket up? Yes? And let's say it hits something. Bam! Doesn't that trajectory then become an entirely different function? So that's, at this, I can look at it as at time 0, and if you've ever watched Space Shuttle launch or whatever, you know that there is negative time, just time before I launch, whatever. So at time 0, something changes. It gets hit by something or whatever the shit. You guys kind of with me? That's one way to look at piecewise functions is it just allows me to define how something's moving as it changes its motion. You guys cool with that? Okay. A good example would be throw a baseball. Pitch a baseball. There's a certain trajectory to it. Hit the damn baseball. Has that trajectory changed?
Yes.
Very much. So at the time when I hit the damn ball, the function that defines its motion is going to be completely different than what it used to be. That's what I use piecewise functions for in reality. Okay. So the question here is, where'd it go? Oh, use transformations. Okay, that's kind of silly. How do I graph? I'm just going to tell you how to graph a piecewise function direct. Don't worry about the transformation bullshit. There's enough going on already. I'm going to do a separate example, just because I don't like doing too much of your homework for you. Make it on the same kind of level. Okay.
So you're saying not to worry about the transformations for that section, or just
For
this
that
problem?
problem, yes.
Gotcha.
Don't get too excited. Okay, so at 1 second, something changes, right? What's it look like before 1? What's this function look like before 1? Or an input of 1, what's it look like? Parabolic, 11. And after that, of course, it looks like a line. Good, line going down, 11. So, guys, one really good way to do this is to make 2 table of values. So if I look at, when is it x squared minus 1? When x is less than 1, correct? So what am I going to put into it then? Maybe -1, 0. Now, can I use 1? Is this allowed to use 1?
No.
But I need to know where to put the open circle. So what I do when I do this is I put 1 in parentheses to remind me. I just need to know where to put the open circle. Where would it want to be if it was allowed to use 1? Does that make sense?
Yes.
Thank you. So I'm going to do the same thing for 4 minus x, bless you. But it could use 1, so I'm going to do 1, 2, 3. You guys kind of with me? Anybody ever plotted piecewise functions? Has anybody worked with piecewise functions before? Does it make sense though in terms of, it's always nice to know there's a physical meaning behind something. And physically, I could have an object moving and then it changes course drastically. So of course, at that time, a new function takes over. So there's a physical grounding for why this would exist. So how do I handle it just graphically, Jeff? Well, I've got 2 functions. They have different domains. I just use inputs that live in those domains. Are you guys kind of with me? So for x squared minus 1, I can only plug in stuff less than 1. I'm going to pretend to plug 1 in just so I know where to put the open circle. So when I put a -1, what do I get? 0. When I plug a 0, I get -1. When I put a 1 in, I get 0. It's doing its parabola thing, yes? It's turning around. Sorry, what?
Open circle would be parentheses.
No, just an open circle on the graph.
I know, but.
Oh, I see. For if I was writing it in interval notation, it would be parentheses. Yeah.
Okay.
And then this is nice, good straight line. 3, 2, 1. Is everybody with me on this? So I want to say this real quick. I saw people shake their heads no, and I'm like, I would never know unless I was looking at you. So please, dear God, understand. Again, if you don't understand something, there are other people that don't. So feel free to just let me know, Jeff, that made no sense. What the hell? No, don't say it like that. All right. So help me out. Where did I lose you? So this is the problem I'm given. I can only use inputs for this one that are less than 1. So let me ask you a more direct question on the side here. Can somebody tell me what g of 3 is? Why is it not 8?
Oh,
Because
it can't-
Because the input's bigger than 1. I can only use this if it's less than 1. Okay, good. You guys with me? Okay, so if the input's bigger than 1, I use bigger than equal to 1, I use this. If it's less than 1, I use that. So when I make my XY tables, I'm going to do exactly that. When I try to make points for x squared minus 1, I'm going to use inputs that are less than 1. I do this just so I know where to put the open circle. For the line, I'm going to start at 1 and go up. Right, and of course I don't need a ton of points for a line. And now I just plot the points. Same graph, totally. It is one thing moving, just at some point it changes. So graphically, I want to see what does it look like. So it's going to look like a parabola, and then it's going to suddenly shift to a down line, yeah? Now this one's going to get a little freaky. Well, let's see. This one is a little bit, might involve some Star Trek stuff. Hold on, I'll tell you why in a minute. Let's guess on something. So let's see, -1, 0. 0, -1. What do I put here? Open circle, 1, 0, yes. Put the parentheses there to remind myself. And then I go 1, 3. So there's my little parabola dude. He's a parabola until he gets to there. And then I put 1, 3, 2, 2, 3, 1. Now, this would be hard to describe as a physical thing, because what happened? If this is some bird flying along, what the hell did the bird do right there?
It's a mole bird, it goes into the ground, comes back up.
Yeah, look at me like a mole rat, yeah. So this kind of teleported to there, right? You guys kind of with me? Let me introduce a word early that we're going to talk about probably tomorrow. Would you say that this is a continuous graph? Where's the discontinuity? At 1. So one way to really kind of very loosely, not technical at all, describe what continuous means is I shouldn't have to lift my pen up. So when I say where's the discontinuity, it would be somewhere you have to lift your pen up to draw the graph. I had to lift my pen up here. Okay. Okay. Is that cool? That's how you do any graph of any piecewise function. There could be 3 parts to this. And then you just make 3 tables. Now the thing I see students do, I see this as an answer. Can anyone tell me exactly why this answer is wrong?
They continue the lines.
Yeah, they include.
Is that supposed to be a function? It's a function. This is a function, correct?
It's a function.
Yeah.
It is.
Otherwise I can't call it g of x if it's not a function. This is a function, yes? Is this a function?
No.
Because it doesn't pass the vertical line test. I love it. So make sure, whatever the hell you end up with a piecewise function, it better pass the vertical line test. The most common mistake I see is people make the whole picture and I'm like, no. It stops somewhere. That parabola stops at 1. Okay, I like it. So for those people who've never seen this before, does that make more sense? It's a math teacher's dream is 2 problems in 1, yes? We love that kind of shit, don't we? We do. I'm sorry. We got it. Yes. Was there any questions left over this? Yes. Sorry, I'll come back to that. Oh, what is anything to the, what's a to the x look like? It looks like this. Yeah. So you can just approximate a couple points. Like if you plug a 1 in, it'll be e to the first power, which is 2.71. You can just do it in the calculator, get a number, and approximate it. Is that cool? That's another reason why I wish they would have used a nice whole number base, so you could actually do it more by hand better. But just approximate it. Does that make sense? So when you make a table, if you put a 1 in, each of the x minus 1 is going to end up being 1.7 something. So then you just approximate that when you graph it. Is that all right? Yeah.
So on the graph, right?
Yes.
When you have that, like when you plot the points 1, 0, that right there, you can do that so that way you'll know, hey, this is where it stops, or
This is where the open circle is, yeah.
Cool. That's it.
Yes.
Can you go over 8?
8.
Yeah.
I think we're gonna end up doing all right. 8.
Yeah, that
Oh yeah, everybody's favorite trig. Let's see. All right, guys. Sine and cosine. And again, if you are somebody who hasn't taken trig in a while, you got to refresh. If you think you've never had trig, please do me a favor, come see me. You and I got to work. We got some work. We got to figure out some stuff. If it's been a while since you had trig, you can still come see me. We have to kind of refresh. Can anyone tell me sine and cosine? Don't look at that function. Don't look at that function. Sine and cosine. Are they bounded? Can they go up forever, down forever?
No.
Hell no. How far up can sine and cosine go?
1.
To 1. And how far down can they go?
1.
Negative 1. Okay. So for the range question, let's do the range question first. Does anyone remember what that 2 does? Let me kind of shift this over a bit. Does anyone remember what that 2 does? It's coming back, don't worry. Put it more up here. Yeah, this 2 does this to it. Yes? You with me? Because all my inputs can be half as big as they used to be because the first thing I do is double them. Does that make sense? So I don't know if you guys remember this. It's kind of the nice thing about cosine and sine is they do look like springs. So when I compress it, it actually looks like a spring getting compressed. Are you guys kind of with me? If it was 1/2, it would have gotten stretched. It'd be like a radio wave. Wow. Okay. So that's not going to do shit in terms of anything here, to be honest. That goes from what to what? What did we just say? That piece there goes from -1 to 1, correct? So then what's the whole function go from to?
3.
Add 3 to those.
So-
That's the range.
So 4 to negative 4?
No. Come on.
Negative
-1 to 1. What's -1 plus 3? 2. And what's 1 plus 3?
4.
So this goes from 2 to 4. That piece goes from -1 to 1. So when that piece is -1, what's the function? When that piece is -1, that's 2, yes? When that piece is 1, 4. So that goes from 2 to 4. Because what is 3 plus 2? Doesn't it just take cosine and lift it up by 3? So if the floor used to be at -1, isn't the floor now at 2? You guys okay? All right. I like it. Maybe can you open that door in the back? Yeah, this building, it's got walls and doors that almost work, but it doesn't have AC to it. Domain. Does this 3 do anything to the domain? Because all I care about is where's the variable? What can the variable be? Is there any input cosine can't handle? No, it goes forever. So what's the domain? All real numbers, -infinity to infinity. You guys got it with me? Never put a bracket on infinity or I want you to bring me that shit. Because you're telling me you can get to infinity. I'm not sure if I want to see that. I wonder if that's what was in the briefcase and Pulp Fiction. Oh, you got infinity. All right. Don't worry, if you've never seen Pulp Fiction, it's not a prerequisite, but you really should watch it. Okay. Anything else? Is that okay for that problem? I mean, I did it. We did it together, so it's got to be okay. Yeah.
Range was, choose a 0 to 1 to 4.
No, not 1. The lowest this piece could be is -1. So the lowest this function could be is 3 plus -1. Does that make sense? This is the only piece that's changing, correct? So if the lowest this piece could be is -1, the lowest the function could be is 3 minus 1, 2. Do the same thing for the max. Yeah. Yes.
So the 3 just shifts the range.
Yeah.
And
It
then-
just moves the whole function up 3.
Right, and then the 2 compresses the domain.
No.
It has some.
The function is defined infinity to negative infinity to infinity, correct? So all the 2 does is it makes it go that quicker. It makes it go through a cycle quicker.
So 1 period would be instead of
2 pi, it'll be pi. Yeah. 2 pi divided by 2. Remember k is 2? Yeah. All right, guys. Yes.
Should be the last question. Number 22.
Brandon is there. No more questions. 22. Where are you? There you go.
A composition of 3 functions.
Let's see. How do I make this? It's a little blurry. Too bad for everybody.
Show the square level thing.
If you do anything to it, you made a different function. So that's like you saying, I see your question, but I don't like it. Let me make it a different one. Oh, that's blurry cell. What has happened to you, poor little dude?
Probably dying.
Poor little dude. Poor little dude. I think it's these guys. I always forget. Okay, is that better?
Yeah.
Okay. Guys, let me ask you this. Can anybody see what the outside function is? Like what's the main thing happening here is 1 divided by shit. Do you guys agree with me? So the f, so let me write this. What's composition mean? Let's start with that. What's composition of functions mean?
Like a compile.
Like composed of stuff. I didn't bring anything. Oh, there it is. All right. So composition would be f of g of h. I hate this notation. I much prefer f of g of h. That makes more sense. Yes? Because then the h is inside the g, which is inside the f. So there's a bunch of stuff inside of a 1 over x function. Do you guys see that? So if f is 1 over x, I can then start to say, okay, what is the innermost thing? There's an infinite number of answers for this one, by the way, but there's like 2 main ones. Isn't there stuff inside of a square root? What stuff is inside the square root? X plus square root of x, yes? So the way I would do this, do you guys notice how it's relatively easy to see the outside function? 1 over shift. That's the outside. That's the main thing happening. And the inside function is the thing that's inside the most stuff. This is inside of a radical, which is inside of a 1 over stuff. That's the innermost dude. So he is the innermost dude. What is he inside of? Square root of x. Yeah. So if you try this, if you shove this in here, you with me? Don't you get this piece?
Yeah.
And if you shove that in there, don't you get the whole function? That's all that's saying is, can you see how to break this down into 3 functions that when you put one inside the other, like Russian nesting dolls? Have you ever seen those? Mm-hmm. Okay. So here's the little tiny doll on the inside. You shove it in this guy, shove it in that guy. Okay. Sounds terrible, but okay, maybe. That one's hard because it's doing what we're used to backwards. Somebody's already made a function. You have to pick it apart. That's a harder situation. Okay. That's why algebra's hard. It's because you're trying to figure out how much money some dude put in his accounts. You're like, why didn't you keep track of that? Well, who the hell are you that you don't know how much money you put in the bank? I wish I had that problem. You guys know what I'm talking about? Those algebra problems you get, the word problems. Okay. Sam forgot how much money. What? Sam's doing fine. I don't have to solve any of his problems. Okay. Anything else? Are there any problems you haven't talked about? Okay. Yes.
I guess just really quick on question 1, G. I couldn't exactly figure out how to determine if F was even, odd, or.
Oh yeah. Okay. Very quickly. The way I remember even and odd. What's the most basic polynomial that has an even power?
2.
X squared. What does it look like? Right? So where's the mirror for x squared? The y-axis. So any function that's symmetric, like cosine. Cosine looks like this, yes? Starting at the y-axis. Any function that's symmetric to the y-axis is even. So not only x squared is even, but that's just the thing I have in my head because 2 is even. So even symmetry is what does x squared look like? Y-axis is the mirror. So odd symmetry, what am I going to base that on? X cubed, maybe. What does x cubed look like? Yeah, it looks like a cactus, yeah? Sort of a weird, whatever the hell you want to call it. Or a giraffe that lost its front leg. It's horrible. Sorry, Corey. So this guy, here's what's weird about that. So if I have a cubic, what is 2 cubed? 2 cubed is 8. And what's negative 2 cubed?
Also, negative 8.
No, it's negative 8, yeah. So this looks basically like that. So odd symmetry is symmetry through the origin. If I draw a line through the origin, I come out to the reflection that's on the other side there. That's a little weird. There's a mirror at a point, but that's what odd symmetry. So look back at the problem that you have. It's definitely not even symmetry. I think we can all agree on that. That is not symmetric to the y-axis. Is it odd symmetry? What is 2? What's an input of 2? What's an input of 2? It's almost what?
Almost 3.
Almost 3. What's an input of negative 2? It's almost negative 3. So if I had to pick one of them, I'd say that's odd symmetry. Right? If I draw a line from the point through the origin, don't I end up at the reflection? You guys got it with me? A little bit?
So
Okay.
what would it look like if it was neither?
Oh, for neither, it would be almost anything. So here's what's funny. This parabolic, yes? Does it have any symmetry? Any even or odd? Let me say it like even or odd symmetry? No. Is the y-axis the mirror? No. Is the origin the mirror? No. No symmetry. Neither symmetry. Does this have symmetry? Yes. Has symmetry. So this line, that's the axis of symmetry. But does it have even or odd? No.
It'd be reflected about a certain point. Which I
Oh,
think-
yeah, if I move, for odd symmetry, you can move like a cubic. I don't know if this is what you're talking about. But it would be symmetric, not through the origin, but through some other point. Is that what you're saying? Yeah, beautiful, exactly. It'd just be shifting, yeah.
So for 19, do we have to make it like when it's asking even odd or neither? Do we have to put like f minus x and then?
Yes, good. So if you have to do it now, what's funny is on part A, well, let's see if you guys are cool. Well, the test for even or odd symmetry is put a negative x in. That's the whole idea. Yes?
Can you just erase the board?
Oh, I'm sorry. Thank you. Yeah, remind me when I do that, because I'm not used to using the projector in the first place. Oh. Where were we again? 19. Okay. So the test for symmetry is plug a negative x in. That's basically what I just did with the cubic, right? Put the 2 in and put a negative 2 in. So if you put a negative x in and the answer comes out the same as the original function, that's even. So if I have x squared and I put a negative x in, what is negative x squared? What's the square root to the negative? Cancels it, so it just becomes x squared again. So it's the same function, so it's even symmetry. If I put a negative x in and it comes out to be the negative of the original function, that's odd symmetry. Yes?
Can you also look at the leading exponent too?
Totally. So a shortcut would be,
Ooh, what is C?
huh? C, you got it, yeah, C's a little tricky. Part A, isn't this odd? The first piece?
Yeah.
And isn't the second piece even?
Yeah.
So if I combine them, I end up with neither. That's a mixture. But if I had like x to the 5th plus x cubed minus x to the 7th, that function is odd because it's got nothing but odd bits in it. You guys see what I'm saying? Okay. But in general, if you're not sure, you plug a negative x in and you see what's happening. So, to be honest, this one's not bad at all. This one. If I plug a negative x in for x, what happens? Where'd it go?
It's always negative, doesn't it?
There you go.
Negative square, right?
Yeah, negative squared is negative still. I'm sorry. Negative squared, the negative goes away.
It's positive.
And then negative outside is still there. So it stays exactly the same. So if you do it, if I plug a negative in e to the negative x squared, if I investigate f of negative x, that's what you're going to do for every single one of these problems. Whatever function they give you, you're going to plug a negative x in. If the answer comes out to be the same as the original function, that's even. If the answer comes out to be the negative of the original function, that's odd. And if it comes out to be neither of those, then it's neither. So what happens when I plug a negative x in here? I get e to the negative x squared.
Doesn't it prevent x from ever being negative?
What's the negative? What happens to this? So that negative's still there, right? Yeah. Is that the same as it was?
Yes.
So what symmetry does that have?
Even.
Even. Duh. If it was the negative of what it was, odd. If it's neither one of those things, neither. Which one? There you go. Gotcha. You can almost read that. Sorry, in the review stuff, I tend to kind of go a little fast because I desperately need to get to the calculus stuff, but please, dear God, slow me down if I'm going too fast. I like to say this. I like to say, if I'm going too fast, slow me down. If I'm going too slow, deal with it. Okay. All right. So, tomorrow, what's happening tomorrow? Quiz. Oh, by the way, before I forget, I was going to send an email and I forgot. Everybody who I authorized to add. Yes, so a lot of you guys haven't added yet. Go ahead and add the course if I authorize you to add yesterday. Okay. So make sure you get in there and you don't have to go through any rigmarole. So yesterday we talked about limits. We talked about finding the slope at a point. That kind of led to the development of the idea of limit. I'm thinking about it. Put power saver on. We can do it. Where's power saver? There it is. Stop it. Don't do it. Okay, good. So let's just remember a few things from yesterday. We already did an example like this. Let's do this. Let's do a concrete example of finding the slope at a point for a function. So let's say I have the function 2 minus x squared. And I want to know the slope at 2. So here's what I do. So here's the idea. This is going to be my x1. What's going to be my x2? What's the idea? So I have this down parabola. I'm at 2. What do I want my second point to be? How far do I want to go away from that? H. So I want the second point to be 2 plus h. So it's just like the problem we did earlier, except instead of just putting an a there, we're going to put a frickin' actual number there. You with me? So instead of being a plus h, we're gonna have freaking 2, because this is a very specific question. What is the slope at 2? Not the slope at A, or the slope at 2. So how do I do that? I need the slope at 2. Algebra says I can't do that shit, so we go a little bit away from 2 to 2 plus h. Now algebra can do its y2 minus y1 business, yes? Is everybody with me? That is the biggest thing to get down right now, because that is how we build all of calculus, is on that idea. So it's a little important. So please let me know if that doesn't make sense. I can't get a slope at a point because algebra needs 2 points. So we give it 2 points, and then the next thing we're going to do is we're going to let h go to 0. So we're actually getting what we want while we're pretending, oh, you got 2 points, algebra. Okay. So the general idea to get the slope is this, y2 minus y1, you go, Jeff, over x2 minus x1. Is everybody with me? Is everybody cool with x2 minus x1 just being h? Because of course a plus h minus a, h. That's the general idea. Now what did I say a was? 2. So if I want the slope at 2, f of 2 plus h minus f of 2 over h. Let me stop for a minute. You're going to see problems just like this in the homework. And on quizzes and on tests, blah, blah, blah. Very much. Is everybody with me so far? I think I've gone through this concept. The concept, let it be, it's easier than you might have thought the basic underlying principle of calculus would be. I want 1 point, so I go a little bit away. Now I've got 2 points. Yay! That's crazy. That's the idea. So, do you see how I need f of 2? Let's do that first. Can you guys just take a moment, don't say anything, figure out what f of 2 is? You should be done. What's f of 2? Negative 2. I like it. So f of 2, negative 2. Is that cool? Now take a minute and figure out what f of 2 plus h is. Don't say anything.
Can you scroll real quick so it's
Yeah, sorry. Yes.
Why is it -2?
Oh, plug a 2 in.
Oh, okay.
Yeah, that's all we're doing is we got the function, and I want to know the function evaluated at these things. So in algebra, you would have been given the outputs. We're figuring out what the outputs are, so we can put the y's in. That's all these are is the y's. The output for 2 plus h, the output for 2. Because the top's supposed to be y2 minus y1. So if I want to know what f of 2 plus h is, here's where you got to be careful. What am I going to put in place of x?
2 plus h.
Holy shit.
Wild.
And here's where a good example of negatives screwing us over if we're not careful. This is 2 minus whatever the hell I get there. Right? So what is 2 plus h squared? 4
plus 4h.
Yeah, good, because you get 2h, 2h
Yeah, plus h squared.
plus h squared. Is everybody cool with that? It's just foiling? Is that cool? Yes?
Yeah.
Oh, that's the function. So evaluated at 2, it'd be 2 minus 2 squared, right? That's where we got negative 2. What if I evaluated at 2 plus h? Don't I just plug a 2 plus h in? So if the function is 2 minus x squared, f of 2 would be 2 minus 2 squared. What would f of w be? For example, 2 minus w squared, yes? Yes? What would f of Jeff be?
2 minus Jeff squared.
2 minus Jeff squared. What will Picasso Jeff do?
Multiply.
So what is f of 2 plus h?
2 minus
2 minus 2 plus h squared. Functions are very single-minded, like whatever the hell's inside, just plug it in. Just do shit to it. Do what to it in this case? Square it and then subtract it from 2. Does it make sense? Don't let it be more than that. Whatever is in here, you replace x with it. That is it. Now we're worried now because we got to actually do this, but we just did it. Not that big of a deal. Here's the thing, though. Be really careful about this. See how I'm putting parentheses? I got to subtract the entire thing, whatever the hell it is. So f of 2 plus h is 2 minus 4. Is that cool? Minus 4h minus h squared. Is that all right? Okay. Distribute the negative. So I get negative 4, 2 minus 4 is negative 2. Negative 4h, negative h squared. Yes?
So I'm gonna backtrack a little bit here. Why did you put 2 plus h in that to begin with?
Why did I put that there?
Yeah.
Are you cool with this? Are you cool with this?
Not really, but
Alright. So it's back. Are you cool with this?
yeah.
Okay. So all we did was, I know what point I'm interested in. Aren't I interested in 2?
Yeah.
So instead of a, I just put a 2.
So you did f2 plus h minus f2.
So we got to figure out what this is, correct?
Yeah.
And we did. We figured out what f2 is. We got to figure out what this is. So that's exactly what all this business is.
Okay.
So all right.
No, I get you there.
I surprisingly, I'm a complete nerd. This is one of my favorite things, is this construction idea. I'm given a problem. It's this. And I'm like, oh crap. I don't know what either of these. Okay, let me construct what that is. Let me construct what that is. And then I'll throw them in there. Right? Because that's what the problem wants from me. And I don't know those things. I'm going to focus on those things by themselves and then throw them in. So now I can throw them in. So let me remind us, I want this. Right, that's going to be the slope at 2. That x equals 2, to be more specific. Right, that's what the slope at x equals 2 is going to be. And now we know what f of 2 plus h is. It's this. Yes? And we know what f of 2 is. What's f of 2?
Negative 2.
So see, again, the negatives try to screw us over. It says minus negative 2. Yes? Beautiful. All over h. Do you guys understand? There's a big thing about mathematics. Math is hard enough already. So don't be mean to yourself. Take this, make it its own problem. Don't try to do this whole damn thing, because that's where you get lost. There's too much shit going on. Take this piece, do it. And now I know what the hell it is, I can plug it in. I don't have too much going on all at once. The one thing you could make a mistake is put stuff back in the wrong place or something. Just be careful when you're putting stuff back in. So we know what that is, bam. We know what that is, bam. What happens that tells me I'm on the right track? I didn't say it this way earlier, but you're on the right track if anything that doesn't have an h cancels. And that does happen, yes? Negative 2 plus 2, die. Yes? Alright, real quick. Everybody's cool with this, yes? Let me know if that's not true. Is everybody cool with this?
Yeah.
Yes?
Sure.
It's okay if you're not. It's only bad if you're pretending like you are. Alright. Is everybody really? No? Okay. Is everybody, so again, this is where I need your help. The minute I lose you, you gotta let me know, because it's hard to backtrack. Everybody is cool with this, yes? This is the y2 minus y1 over x2 minus x1. That's what that is. A, I replaced it with 2. The minute I do that, I need to know what this is, or else I can't figure this out, yes? And I need to know what this is, or else I can't figure out this. So I figure out what f of 2 is, and I figure out what f of 2 plus h is. That's what all this work was, yes? So now that I know what f of 2 plus h is, I can take this and shove it in there. And now that I know what f of 2 is, I can take this and shove it in there. And that's exactly what happened here. We put f of 2 plus h, which is here, minus f of 2. Do you see that? I took f of 2 plus h, and I plugged it in here. and I took f of 2, and I plugged it in there. That's all I did. Is that alright? Yes.
Why can't you multiply -2 and the -2
Where are we at? Sorry.
right there? Like, why can't we multiply them together? -2 times -2.
Which -2?
That -2.
This -2?
Yeah, and the other -2. Why can't
Way
you
over there?
multiply them? Yeah.
Because there's no multiplication between them. What's the only operation in this whole thing? Subtraction, really, right? There's no multiplication in here unless you say 4 times h, right? You with me? Okay. So what do we got so far? Somebody help me out. What's left here? What's left alive?
Negative 4h minus h squared over h.
Thank you. What happens now?
Take out h right.
Yeah, if I take an h out of the top, it can cancel. Now, I purposefully did not do something that we will do later, because we're still learning some shit. What would be the next step to actually get the slope?
Find h.
Let h go to
Zero.
0. So, in the future, when we're doing this problem for real, from the very beginning, we're going to have a limit as h goes to 0 here. And all it's going to do is it's just going to come for the ride. Whee! Whee! Because you can't do shit with it until you get to the very end. Can I plug a 0 in for h here?
Yes.
Could I have done it up here?
No.
Nope. But I can do it now, yeah?
Sure can.
What do I get?
Negative.
Holy crap. What did we just find? What the hell did we just do? We found the slope of the function at 2, right? At x equal 2? Okay. Is everybody with me? So in algebra, what letter would we say -4 is? Slope. Slope, of course we use m for slope. Why wouldn't you? The urban legend about it is it comes from French marcher, to walk, because slope kind of tells you how to walk around. Go up, go over, go up, go over. So that's where people think the m came from. Probably just somebody just made it m. I don't know. Somebody semi-okay. Yes? Yeah, we're still in the development of concept phase. If to do the question as I asked it, the limit should be there from the beginning. But I didn't want to bring that in too early. I want to focus on what we're doing. But now we know, I know I'm going to want h to go to 0. So we'll have it from the very beginning. And it just, like I said, it just sort of comes from the ride until I get to this point. Now, yes?
So you just make h 0, so it's -4 minus 0.
Totally. Real quick, just make sure you guys, this division can happen everywhere except if h is 0. So why am I allowed to do this? Because the limit doesn't let h go to 0. It just approaches 0, correct? So that's why I'm allowed to plug a 0 into the stuff that's left over to get what the answer is. Okay. So that's the slope. Somebody remind me, what was the point? It was 2, -2, yes? You guys with me? So the point we're dealing with, I originally just told you the input, but then we figured out the output, yeah? So we know we're at the point 2, -2. Can anyone develop, please, the equation of the line with that slope going through that point? Does anyone remember how to do that?
Y minus
Yes.
y
Y minus y 1 equals m times x minus x1. Yeah. Or you could use y of mx plus b, to be honest. Believe it or not. We don't know b, do we? What's b from mx plus b? What's b?
That's the intercept.
That's the y-intercept. Do we know the y-intercept?
Wow.
No, damn it. But so how the hell can I use it then? Well, I know y, m, and x, don't I? Solve for b. So I agree with you. And in fact, the funny thing is, I sort of want us to use that because later this semester, that formula is going to become important again. So let's do it that way first. Does anyone remember this formula? Besides the people that just helped me put it together? You guys, does that look familiar at all to anybody?
Yeah.
Real quick. Isn't m y2 minus y1 over x2 minus x1?
Yes.
Does it matter what points I use from a line? Does it matter what points I use from a line? Is the slope ever going to change? The whole idea is the slope doesn't change. So I'm just going to say this could be any point. This could be any point. It doesn't have to be a specific point. So I take the subscript away. Then I multiply this shit up and I get this. That's all that is. That's all that is. If I multiply that up, I get this. That's it. Nothing amazing. I'm like, yes, Jeff, that summarizes that. So y minus, what's the y piece of our point?
Negative 2.
Negative 2. Equals, what's our m?
Negative 4.
X minus the x piece. 2. So you get y plus 2 equals negative 4x plus 8. Is that cool? Y equals negative 4x plus 6. Is that cool? You can always check your work. When you plug a 2 in, you get negative 8 plus 6, negative 2. So when you plug a 2 in, you get negative 2 out. Yay. Yes, sorry? Which part? Everything you just did, Jeff. Starting here? Okay. We know all of this, correct? Y minus the y piece of the first point, the only point. What's the y piece? Negative 2. Equals m, x minus the x piece. And then I just solve for y, right? So put it into mx plus b. Jeff. So we got that, yep. Just to show you real quick on the side here, if I use this formula and I plug in negative 2 equals negative 4 times 2 plus b, negative 2 equals negative 8 plus b, add the 8, I get 6 equals b, which is what it is. Hey, holy shit. So that is a valid way to do it. Let me stop for a moment. So, by the way, guys, whenever this happens this semester, I'm going over something that I'm assuming everybody knows. Some of you guys are like, sure, dude, it's been 10 years, okay? So that's where you do exactly what just happened. Hey, man, can you don't do that. Hey, math boy, over here. No, don't do that. Hey, Jeff, can you do that again slower? That was beautiful, right? So that's what the help I need from you. Yeah. To find a line. So we have two equations of a line. We have mx plus b. That's an equation of the line. And we have y minus y1 equals m times x times y. So what did we just find? We found the tangent line to this curve. So what am I going to do now? I'm going to show you in Desmos the original curve, and we're going to graph the tangent lines. Anybody never heard of Desmos? Anybody know Desmos? You guys know Desmos? If we had enough computer labs, basically if we had enough money, we'd have more computer labs, and we could teach more math classes using freaking computers, and we'd use Desmos instead of TI. But we don't. None of that's true. So let me show you, and then we're going to take a break after this. I got to talk about that. I keep forgetting to talk about this. This is up on Canvas, by the way. This is a timeline of mathematics. I love that they keep adding more people. So you can see all the, and it goes way back. Way back to the very first discovery we made related to mathematics. So you can go through, you can find people, you can find Euler that I was talking about earlier. Fibonacci, do you guys know the Fibonacci sequence? So you can find all these contributors. I like that they go out of their way to try to find the contributions from different genders, different ethnicities, right? So unfortunately the past is dominated by white men, when actually a lot of the work was not being done by them, they were just taking it, right? Which sounds like a general theme of the world for a long time. Anyway, okay.
What is the green and the red?
Oh, green is like, oh crap, it's been a while since I looked at that. Yeah, there is color coding, isn't there? I think it's just to make it easier down here. maybe?
Maybe like a timeline.
There is a point to the green. I can't remember what it was. Maybe. Sure. All right. Let me get out of here. There we go. Okay. Desmos. So if somebody would look at the website, remind me what those colors mean. That'd be awesome. It's not your job, but if you want to, that'd be great. All right. So I'm gonna plot. Somebody help me out. What was the original function? Was it 2?
F of x, sorry, yeah, f x, 2 minus
2 minus x squared. Okay. All right. Desmos kicks so much ass because watch. If you never used Desmos before, if I click on the function, it automatically tells me the y-intercept and the x-intercepts. I just hover over them. You see that? That's silly. Zooming in, zooming out. It's nice. Now I'm gonna graph. What was it? Negative 4x plus 6.
Yeah.
So what should this look like?
A line.
At 2, negative 2, it shouldn't look like this shit, yes? What should it look like? It should look like line coming in, touching there, and then continuing. It should be, if this sucker was on, and all of a sudden it flew out, it would fly off in a straight line. I sort of like me swirling around and letting go, right? So it should look like this. Let's see what it looks like. Bah! Look at that shit! Sorry, I'll come back. Isn't that cool? I mean, come on. Anybody? Come on. We just did that. We just did that. And then the computer's like, oh yeah, you're right, human. Yes. Say again? Tangent will always be well, alright. For us, it will always be linear. I mean, you go high enough in math, you can get all kinds of weird shit. But for a long time, it's going to be straight. Yeah. So like if you go to Calc 3, you can start talking about tangent planes. But we're not going to do that. We're going to keep it there. All right, so let me stick to my word. Let's take a break. Come back at 11:35. And then towards the end of class, we're going to take a little field trip. So we're going to leave before 1, and I'll let you guys out around 1. Okay? Yes. It's crazy. So again, I don't have a worksheet for every little thing, but you never know. I got a stupid amount. I've been teaching since, how long do you guys think I've been teaching?
You've been teaching since 2005.
Since 1998. I started teaching when I was 26. And I looked like I was 17. So everybody was like, I'm the teacher. Yes, I am. Huh?
On the test, is it mainly like pre-calc knowledge? Like what I should be doing?
Yes, pre-calc stuff, yes. I love that. Yes.
Do you happen to know what sections we're doing today?
Yeah, I'm hoping to get through 2-3. Yeah. All right, guys. So. Did I turn it on? Yes.
Is the quiz tomorrow going to be basically what we did yesterday, like for review?
Yeah, but more on the homework. I'm gonna try to give you some modified questions based on the homework questions. Yeah.
I really like where Coyote first and like use a little baby questions.
5 questions. Never open book, open notes. Never. Because I'm evil. I'm an evil person. I don't know. As a teacher here, I can take any course I want to for $2. I haven't been able to do it forever. I took yoga, I took creative writing, I took nonfiction writing, I took some other courses. I'm part Native American, so I took this Native American history class, it was interesting. And every test was open notes. And I was angry, because I knew I wasn't going to remember any of that shit. If they had forced me to actually do it without notes, I would have actually retained some of it. But since it's open notes, I'm like, I don't have to remember any of this stuff. I just look at the notes. The kid next to me, I got my results back. He did Scantron. And I got a 63 out of 65 on her first test. And I was really mad at him. I was like, how did I miss 2? I got open notes. The kid next to me is like, how did you get a 60? He got like a 27. I'm like, it's open notes, dude. What the shit? So, All that's to say, no, I never let you use OpenNotes or OpenBook or any of that. You don't want me to make a test where I would let you use OpenBook, OpenNotes. You don't want that from me. Trust me. Yeah.
Calculators on the test?
Calculators on the test.
Oh, thank God.
I'm just Jeff. Okay. So just to show you some example problems from the homework. So for example, this guy, look at number 6, this is section 2.1. Read through that real quick.
Like a physics problem.
So again,
It's like a physics problem.
It's a limit problem.
totally, yeah.
Is it like
Every science is based on, well, uses mathematics. Math is the most basic science. So we're going to see physics problems for sure. Are you going to actually have to apply physical concepts? No, because the functions are already constructed. Physics would tell you to construct the function. We have the function we can use. I don't care where that function came from. It doesn't matter what it represents. I can do shit to it, yeah? It just happens to represent throwing something up in the air on Mars. If we're on Earth, this number is 9.8 because our gravity is stronger. So this 1.86 number is based on the gravity on, this is actually 4.9, sorry. On Earth, on Mars it's 1.86, okay? You don't need to know any of that shit. Doesn't matter. What's this asking me for?
The average velocity.
Yes. So this is the height. This is how high up in the air it is. What is velocity in terms of position and time?
The speed at which you're going at that time.
Change in position over time, yes? You guys kind of with me? You guys kind of with me? So just to help you with this kind of problem, guys, just to help you with this kind of problem, what it's really asking you is find the slope of the function over that interval. So how do you do that, Jeff? Jeff boy. So what is the slope function? What the book calls the difference quotient, right?
Of A plus H minus
So let me give you a different formulation of it.
the limit as H.
The first one we actually did. So here's one representation of what they call the difference quotient, but we know it's the slope. Don't close book, or go ahead and close your book. Oh my God, Jeff. You can almost spell. It's amazing. Difference quotient. So we know that means that's the slope. The first way I did this was actually something like this, which looks a lot more directly like y2 minus y1 over x2 minus x1. So if I look back at this question, now that my book is closed, what this question is asking me, multimedia presentation here. What this question is asking me is, can I find the slope of the function from 1 to 2? So isn't x2 2 and x1 is 1? How do you get f of x2? Well, you just plug a 2 in here, yes? So I'm going to use this function. So just to do an example, I think this is one that I assigned. Maybe not, I can't remember. So if it is, we're going to do one part of the problem. Yay. So how do I do this? I need to know what f of 2 minus f of 1 over what? 2 minus 1. Great. How do I figure out f of 2? Okay. Maybe I'm just going to do this much. Once you see what the question needs from you, you just have to do it over and over and over again. Can anyone see what part A is trying to get?
The
You see
limit-
that we're approaching something, we're getting closer to something.
The limit is x approaches 1.
Yeah, limit is x approaches 1. I'm trying to figure out what is the instantaneous velocity at 1 second. So 1 to 2 is an approximation. It's probably not a great approximation because 2 is kind of far away from 1. I get closer, I get closer, I get closer, Once you get all those figured out, you can see a pattern. What does it look like it's approaching? So maybe if it was 7, 5.4, 5.1, 5.03, 5.01, I would say it's freaking 5. Do you guys see what I'm saying? Could it be not quite 5? Yeah, well, but we're just approximating based on estimations, based on patterns we see. Are you guys with me?
Yes.
After this section, we're going to learn how to do it exactly. In fact, we already sort of did an example where we figured it out exactly. We just did it just a little while ago. You guys semi with me? Basically, every problem in section 2.1 roughly is related to this. They just have, see this problem? See how it's really the same except they already give you the outputs? You don't have to calculate them, you just have to throw them into the equation. That's even easier if you let it be. Let it be. So that one's like that one. There's one that gives you a function, right? You just have to realize that they're going between 2 and this point. Do you guys see what I'm saying? So x2 would be 2, x1 would be 1.5, x2 would be 2, x1 would be 1.9. Are you guys with me?
Yes.
Okay. Okay. So I want to focus the rest of the class on the idea of limit by itself. We're going to talk about, no, we're not quite to continuity yet. We're going to talk about some algebraic stuff about limits. That sounds painful, but it won't be. It just sounds painful, I know. I've got a handout I want you guys to work on, and then we'll call it a day. So then we'll do the tour. The tour is going to consist of us walking about 30 meters that way, so I'm sorry. I shouldn't call it a tour. That's false advertising. So. Let me do this, because if I try to draw a picture, it's going to be horrible. So, here we go. Let me see what you guys just get from your gut intuition here. Oh shit, wait, too much. Okay. So, can somebody read this for me? So this is A of x. This is a picture of A of x. What is this asking me? The limit is x approaches negative 3 of the function a, yes? Another way to say this, the exact same notation, I can say, what are the outputs doing as the inputs approach negative 3? You guys with me? That's another way to say that. Okay. Looking at the graph, don't say anything for a minute. Can you figure out, don't say it, what that limit might be? As the inputs approach negative 3, what are the outputs doing? All right, who's got the answer?
Going to infinity.
Going to infinity. I love it. Now, let me break this down. Aren't there two sides? I don't know if you guys remember yesterday. Didn't we approach, I can't remember if it was 1 or what. Didn't we go 0.9, 0.99, but didn't we also go 1.1, 1. Didn't we go at 1 from both sides? So do you notice how from the right, it's going to infinity, and it agrees with what it's doing from the left? There would be a major problem if it was doing this. Does it do that? Yeah, no, it doesn't do that anywhere. I'll get another one. Then there would be no limit. It doesn't even agree on how it's going crazy.
Actually, it's
Yeah, 2. Okay, thank you. So at 2, does it ask me about 2? Yeah, okay, okay, wait, we'll get there. Okay. Does that make sense?
Yeah.
So it definitely goes to infinity at negative 3 because it goes infinity from both sides. So yes,
What are the two has?
we're getting there. So this is the problem I just highlighted, right? I should be able to talk about the limit from both sides. What's the limit as I approach 2 from the right? As my inputs go towards 2, what are my outputs doing?
Infinity.
Going to positive infinity. So that would be this. See the little plus sign? That means from the positive direction, from the right. Are you guys with me? I'm sometimes going to say from above, which is bad because people think above means here. Above means here. Yes? This is all about what x is doing. You guys with me? As x approaches 2 from the right, the outputs are going to positive. What's happening as I approach it from the left?
Negative.
Goes to negative infinity. Okay, does everybody get that? Yes?
So what we're doing is, with the limit, we're describing, the limit is the isotope, and then we're describing what's
No,
happening.
careful.
Yeah.
That's why okay, don't worry. We'll do a different example. The limit could be infinity. This example so far, we've looked at some infinite limits, correct? Let me do a different problem here. What about here? Good. Number 7. No, I'm just going to zoom in. I'm going to make my own questions. Screw it. All right. Yeah, got it. There you go, Jeff. What is the limit as x approaches 2 from the left? So you let your inputs approach 2 and you look at what your outputs are doing as you get closer to 2.
About
One,
2.7.
almost
2.8.
2. I mean, almost 3.
Yeah, almost 3 is 1, 2, 3. So like, if you had to guess, you'd say like 2.7. Some of the homework asks you to make estimates. So it's good to get this kind of down. Does that make sense to everybody? Because when you first see this, I always get somebody who's not really sure what way to look at it. And I understand that because you're like, there's kind of a lot of shit going on. But as my inputs, what are the outputs doing as I let my inputs get closer to 2? My outputs are going to 2.7. Do they get there?
No.
Does the limit give a shit?
No.
Because the limit never gets there. I don't want to get there because then my car goes into the freaking hole there and it's not good. That's kind of a big hole. Oh shit, right? We might have go, ooh, okay, let's back up. Of course, what's the limit as x approaches 2 from the right?
1.8.
Well, that's like
1.7.
1, right? 0, 1.8, 1.7. There's no perfect answer. Just don't say 1.4, right? 1.7, 1.8, 1.9, any of that stuff I'll take. You guys, everybody really with me? Okay. Yes?
So you said in the other one, since it's approaching from -3, it's going from the out. It's going to the right.
Okay, wait. Where are we at? Sorry?
The other one you did before.
Oh, the one from the left. Or you mean the other example?
Yeah.
Oh, this, oh shit. Was it this guy? Here, this guy. This guy?
Yeah. So
Okay.
you said the limit approaches -3. Does that mean it's going to the right?
Yep. So the funny thing is, if it doesn't have a plus sign or a minus sign, that means from both sides. So if both sides don't agree, what's the limit? Doesn't exist. So on this problem we just did, what's the limit as x goes to 2?
Besides.
What's the limit as x goes to 2? Does not exist, because they don't agree. So if I'm on the phone with my buddy, we're like, okay, come on, man, there's a giant hole. All right, let's all meet at the giant hole. All right, I'm here. Oh shit, we're not in the same place. So we didn't agree on where we were going. Does everybody get that?
Yeah.
What about here? What's the limit as x goes to 5?
About
Roughly.
1.6.
1.8.
Yeah, 1.6, 1.8. I'll take any of that shit. Yes.
What if we say, like, for the very right line, what is the limit of that? X goes to -3, or Y goes to -3.
We're not talking about the limit of y.
Oh, sorry.
We could, but we're not going to.
Oh, I thought, okay, well, it's going down or.
No, so here I'm going to have to assume it stops. I wish this good was better, but it's not. It's too
Okay.
bad. Too bad for all of us. You guys kind of with me? What's the limit as x goes to 2 from the right? I'm sorry, as x goes to 5 from the right. Same damn answer, correct? They just both agree, so I don't have to put a plus or a minus because they agree. I can just say limit as x goes to 2. I don't have to be specific because they agree. You guys with me? Is it continuous through here?
No.
Why not?
Because there's no circle.
Open circle, I love it. So this is me getting a little ahead. This is actually section 2.5, and I don't care because it goes right along with what we're talking about. To be continuous through a point, not only does the limit have to exist, which means they agree, the function has to actually get there. So that pothole has to be filled in, right? And it ain't. Just to be beautiful grammar. I'll show you why I teach math. They didn't fill the pothole in, so that's discontinuous. Have to drive around that sucker. Okay. That's a big ass pothole. What's f of 2?
There's two points.
Nope. The problem is there's no points. So what's f of 2? Undefined. Does not exist is fine. Undefined. You guys kind of with me? Does everybody see that? Yes?
So the limit would be, the limit would be what? Y?
So y, so at this point, what's f of 5? What's f of 5? Undefined. But what's the limit as x goes to 5? 1.6. So does the limit need the function to exist at that point? No, because the limit never gets there. You guys with me?
Yeah.
But to be continuous, it has to be defined there. Okay. What's f of 4? No, there isn't. There isn't. No, what's f of 4? Yeah, 2.2. Sounds good. See? Isn't it defined here? Filled in, dude. Okay. I love you guys. Is this, you guys kind of with me? Let this.
I don't like the wording though.
Yes?
Wait, but you had said if the points weren't at the same.
Then the limit does not exist.
Oh, okay.
What is f of 4? Where did somebody put the point for an input of 4? Did somebody put a point somewhere for 4? They did. So that's f of 4. F of 4 is 2.2.
Okay.
What's the limit as x goes to 4? Does not exist because they don't agree. What's the limit as x goes to 4 from the left? 0.5 looks like, yeah? You guys, is everybody with me? Now I understand it's very easy to kind of confuse these things, but they are pretty distinct. Limits don't need anything happening at the point because they never get there. They just are all about what's it look like I'm going to do. Right? Function values have to be there or else it's undefined. Continuity needs limits to agree, and the function's got to actually be there. So if that hole was filled in, it would be continuous. So is this function continuous at that point?
No.
Yes.
Oh.
Do the limits agree?
Oh yes.
Yes. Does a function exist here?
Yes.
So it's continuous there. Can I draw that without picking up a pencil?
Yeah.
Yes. Kick ass. Again, continuity is actually section 2.5, but it just goes perfectly with what we're talking about. Screw it. I'm going to throw some new shit on you from the future. Okay. I am from the future. Blah, 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 blah. Okay. Oh, here, look at this guy. Let me ask you this question. Let me see what you guys think. What is the limit? Let me see. The limit as x goes to infinity of sine x. We haven't done an infinite thing yet, but so if I let x get really, really big, is sine approaching something? Why not? What's sine doing always?
Always increasing.
It's always oscillating, correct? So if I let x get really, really big, so let's see. So what has a limit then? So for example, does this have a limit at infinity?
But it keeps going.
This guy. If I let x get really, really big,
Gets really good.
what does that approach? Hopefully we're sorry. 0, yes? You guys cool? You guys with me? That goes to 0. No question about it. Does it get there?
No.
But it goes to it. And what do I mean by that? I can get as close to 0 with this function as you want me to be. So if you say I want you to be within 1 millionth, well then I just let x be a million. Then I'm within 1 millionth of the 0. Oh, well then I want you billionth. Okay, just make x a billion. You guys kind of with me?
Yeah.
So as close as anybody wants me to be to 0, I can get that close. That's what a limit means. So if the limit is 5, I better eventually get as close to 5 as anybody would want me to. That's what the limit means. That's section 2.4. Yay. Coming back to this now. Is there a number that sine gets close to forever at some point as I let x get big?
There's 2 of them.
No. There's an infinite number of them, to be honest. You're thinking about 1 and -1, but doesn't it go to every other point between those two?
That's true, yeah.
So that's what we call, you remember we talked about discontinuity earlier? So if they don't agree, that's a very obvious discontinuity. If there's an open circle there, that's a discontinuity. Another way it could have a discontinuity or an undefined limit is if it's oscillatory. If it's oscillating, it's not agreeing on something. It's not saying, oh yeah, I'm approaching this. It's always
changing.
the same distance from anything. Yeah. It's never getting closer to something forever. Okay, so this, what is happening right there? But what can you guys see how the cycle, the period is getting smaller and smaller and smaller? So how many times is it going up and down right there? Infinite amount of times in a infinitesimally small area. So does the limit exist at 5?
No.
Shit, no.
No.
Hell no. It is infinitely oscillating. Right at 5. That's freaky. So this, all right, that's all I'm going to say about this. So that's the oscillatory type of not existing limit. It just oscillates. It doesn't agree on anything. Okay. That's kind of a freaky point. Let me ask a kind of like a side question. Like here, is there a top of the hill here? Is there a local maximum here?
Yes.
Yeah.
Yeah.
Say so.
And I would, you can estimate what the hell it is. Is there a local maximum here?
No.
Because where it wants to be,
It's not.
there's an open circle, so it doesn't exist. Yeah? Okay. I like it. You guys semi with me? Okay. So one thing with graphs, I'm going to give you a graph. I'm going to ask you about limits, right? So for example, the limit as x goes to 2 is no, and limit as x goes to 2 is no. The limit as x goes to 2 is what's the function? What's f of 2? Undefined.
The limit is 2.
The limit as they approach, the inputs approach 2 is 2 total. Limits never have to get there, so it doesn't matter if there's an open circle. No, it doesn't look like I'm getting closer to 2. That's what a limit is. F of 2 says what is it right at 2, and we're like, avoid, right? Don't drive through that.
Can you explain that one more time?
I'll try. So when I say what's f of 0, why can you tell me the answer? What is f of 0? It's 1. It's definitely not -1. Why? Open circle. So what is f of 2? Is there any closed circle there?
No.
So f of 2 does not exist. Undefined. Is that all right? That's it. If I close that circle, f of 2 would be 2. If I put a circle there, f of 2 would be whatever the shit that is. Right? You guys got it with me?
So when you're asking f of 2, there's nothing there. Is
There's
that-
no output there. So
Right.
do you agree with me that f of 0 is 1?
Yeah,
Why is it not -1?
because it's open there.
So if I made that open also, would f of 0 exist?
No.
Why is f of 0 1? Because that's closed. That's shaded in. So if I made that an open circle, would there be an f of 0? No. There you go. So is there an f of 2? Nope, there's no closed circle there.
But what
There's no
about limit?
output there. No?
But what about a limit?
Oh, sure. Okay, beautiful. The limit is 2. The function does not have a value at 2. Those are two separate ideas. Are you guys with me? You're all like, we're in the same room with you. Okay. All right. What's the limit as x goes to -3?
What are you talking about? Oh, that's
Well, no, the limit is actually
The limit is 4,
Yeah.
right?
Not negative.
What's f of negative 3? Undefined, does not exist. I love it. You guys get that?
Yeah.
Don't get me wrong. That is so easy to confuse. Just remember, the idea of a limit is I never have to get there. So it doesn't matter what is happening right at the point. That does not matter. F of a point, all that matters is what's happening at that point. That is the only thing that matters when I say f of negative 3. And if it ain't shit happening, then f of negative 3 doesn't exist. Yeah.
And then if we want to take the limit of 0 from the right, it would be -1, and from the
So
left.
the limit is x goes to 0 from the right. That would be, yeah. As I approach 0 from the right, it's going to -1
But then the limit as it approaches from both sides doesn't exist.
because they don't agree.
Okay.
So what's the limit as x goes to 0 of this function? D and E does not exist. I love it.
So, okay, so the reason why they don't agree at those points at 0 is because it's not.
They're separate. Yeah, they go to different places.
Right.
Yeah.
And it's like a.
It's like that piecewise function we did earlier, right?
Is it like a continuity thing?
Totally. Is it continuous at 0? No. Is it continuous at 2? Is it continuous at 1?
Yes.
Totally. There's no open circle there. It's beautiful at 1.
Yeah.
Should have said it public. Yes.
So limits exist, but as a function, if it's open, it just doesn't exist.
Yeah, a limit can exist at a point, but the function does not have to be defined there because limits have no idea what is happening there. They just know what it looks like it's doing.
Yeah, so it's just kind of like, oh, cool, limit as a function.
Yeah. So watch this. If I did that, what's f of 2? What's the limit as x goes to 2? No, the limit as x goes to 2. 2. Limits don't give a shit what's happening at that value. Function questions, f of 2, they only care about what's happening at that value. You guys with me? So the limit is 2, because what's it look like the function's doing as I let the inputs go towards 2 from both sides? It looks like it's going to 2. Does it go to 2? No. Sneaky little thing. Right? Little function. You guys go with me? I understand this could get kind of muddled. I'm desperately trying to make a really big distinction. Limits just care about what it looks like it's going to do. F of something completely cares about what it actually does there. Right? Okay. I like it. Hey, Mikey. Okay. Blah, 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 blah. Bless you. Oh, the last thing I want to talk about, and then I got a worksheet for you, is some more of this algebraic stuff we did. Wait.
This is like fading in and out. Like.
There we go. Let's see. Okay. The first thing you try, I'm going to erase this. First thing you try when they give you a limit question, who knows the first thing I try to do to answer this question? Try to plug 2 in, because maybe this function is defined at 2. Maybe it's a little closer, and then I can just find the limit by just plugging the frickin' 2 in. Will that work here?
No.
I can see immediately it won't work here. So what's the first thing we try to do? Instead of making it, we could make a table of values and put 1.9, 1.99, 2.1, 2.01, and see if we've done that before, yes? And you're gonna have to do that in your homework. But we can be a little bit more creative about it. Can we do something algebraic? What can we do?
Factor.
By the way, what is it? What do I get on the top when I make x2?
Negative.
No. When I make x2, what do I get on the top? 4 minus 12 plus 8 is 0.
You can't do 2 either, right?
So this is 0 over 0.
So it's 1.
Real quick question. What is 0 divided by anything?
0.
What's anything divided by 0?
0.
It's the, what's that other word?
Infinity.
Undefined or infinite.
Oh, okay.
So 0 on top means it's 0. 0 on the bottom means it's infinite. So 0 over 0 is somehow infinite and 0 at the same time.
Paradox.
So we call this indeterminate. My God, Jeff. Math is my first language, so you want that. Indeterminate. That's going to become big later this semester, but I might as well tell you about it now. The funny thing is, that seems horrible, but that tells me that the algebra is going to work, because I can maybe cancel the problem. What is the problem? Why can I not plug a 2 in? Stupid x minus 2. So if they're both 0 at 2, that means the top has to have an x minus 2 factor. I can kill the problem, right? It's not a life lesson, by the way, kids. Please don't do that. So somebody started doing this for me a second ago, and I stopped. I'm sorry. What?
X minus 4, x minus 2.
Yeah. So then I can kill the problem. Can I plug a 2 in now?
Yes.
Yes. So limit never gets to 2. That's why I'm allowed to kill this. And now I can plug a 2 in. What do you get? Holy shit. By the way, I know not all of you have your calculator. We're not going to do a lot with the calculator right now, so I'm not going to try to pass any out, but just watch. If I graph the original function, oh crap, I'm in weird stuff. So if I put in here x squared minus 6x plus 8 divided by x minus 2. If I graph this thing, it looks like a line. In fact, it looks like x minus 4. But notice now the calculator's not able to do this. But do you guys, all right, is everybody cool with me so far? Yeah, this is cool with what I'm saying. If I do second trace to go to calc, has anybody seen this menu before? If I go to value number 1, if I try to tell it to tell me at 2, look what it says. What's it say? Y equals, I don't know. So there's actually an open circle there. It's just a very tiny one. I can't see it. If I do anything else, what's the value at 1? It's completely fine. You guys kind of with me? So that's how a calculator shows you an open circle. You actually have to go find it. You actually have to tell it, what is the x? And it goes, y equals unfinished sentence. You know, something. Thanks, calculator. Okay.
So it would be an open circle there?
There's an open circle there. It's just very tiny. Yeah. Okay. Somebody remind me, what can I do with something like this? Shit. I'm trying to make something on the fly. It's always exciting. Oh. Shit. That's, no, sorry. Hold on. You can do it, Jeff. Can I? There we go. No, you can't do it. Hold on, guys. Oh, no, it's terrible. It's the worst thing ever. Let's see. Yeah, 5 will work. Yes. Okay. It's always exciting trying to make one of these on the fly. Yeah. Thank you guys. What the shit? Can you factor this? Not easily. You actually could, but nowhere near easily. So what should I do? Rationalize. Well, sort of. This is the first time you might have seen this, but I'm going to rationalize the numerator, not the denominator. The denominator's fine. I'm going to multiply the conjugate. What's the conjugate at the top?
Square root x
Plus 4.
Good. So each term I leave alone. I just change the middle sign. We did something like this yesterday. So I highly recommend you do not multiply the bottom out. Curious how this is going to work out. So then I get x squared minus 9. Square root of x squared minus 9. So square root of x squared minus 9 is? X squared minus 9. Negative 4 times 4? Minus 16. And of course the middle terms cancel. That's why we do conjugate, because the middle terms cancel. You guys with me? I get minus 4 rad stuff, plus 4 rad stuff, they die. Yay. So what do I get?
We get difference of squares.
X squared minus
25.
25 over x minus 5 times a lot of shit. Let me stop for a minute. By the way, does everybody think this problem is going long?
Yeah.
Oh boy, but adjust your perception. This is a short little problem. Okay.
Just kidding.
What can I do now?
Difference of squares.
Beautiful. So now on the top,
X minus 5.
x plus 5, x minus 5 over x minus 5 times stuff. These cancel, yes. The problem just canceled. Do you understand? Now can I plug a 5 in? What do I get? I get 10 over 25 minus 9 is 16 squared is 16 is 4 plus 4 is 8. So you guys 5 fourths. So that is algebraic simplification. The limit I had to consider at first, I cannot do. I cannot plug a 5 in. But I can do some algebraic simplification and then I end up somewhere that I can plug a 5 in. A lot, okay? Yes?
Can you go over how you got
Oh, sorry. Plug a 5 in. 25 minus 9 is 16 squared is 16 is 4 plus 4 is 8. Yeah. I just did it. Sorry. Yes?
I noticed on the homework, where it says limit x is approaching like 5, there's like a minus on the backside.
Oh, yeah.
So, I didn't do that.
So that would be something like, if I ask you this. Now we already talked about what the plus and minus means. What does that mean? So I'm approaching it from the right. There's a reason that has to be there. Does anyone know why? Natural log of x. Well, it goes like this.
Well, yeah, but if there's nothing over there.
Nothing over there. There's an asymptote at 0, and it doesn't exist for negatives. So I can only approach 0 from the right. Does anyone know what the answer is? So sometimes they'll have like from the left or the right just because. Sometimes it'll have to be there because if I don't put a plus sign there, it doesn't even make sense because it doesn't even exist from the left. Is that cool?
So minus would be
Approaching from the left, plus is approaching from the right. Just like we were doing earlier. Yeah. Anybody know what this is? Negative infinity. I love it because the natural log goes like this. Right? Okay. Alright, I'm going to finally shut the hell up. My God, this guy talks. I want you guys to work on a worksheet. Alright, guys. I know you're not done, but I got to a point where I'm like, I don't want to say the same thing over and over again. So let's look at this last one first on this first one. I think most of you guys get the idea for these two now. Like the first one, what do I do? Yeah, you can always, dear God, before you do conjugates and weird shit, just go, can I factor something? Try that first, guys.
The second one you conjugate, right?
Second one, the big trigger is there's a radical.
Yeah.
You gotta conjugate.
So you use a conjugate.
Is the answer 0 for B?
I don't think so.
And you do plus 3 square root x plus
Alright, let's do these in order. So this first one, take a 4 out. You get that, right? Yeah? Now, a lot of you guys, the 4 just sort of went away, but that doesn't make any sense. There's nobody there to kill him. But there's somebody there to kill him, right? And again, when you're doing these limits, and they're indeterminate form, they're 0 over 0, and they're very simple functions like polynomials or radicals. You're guaranteed that something's gonna cancel. And what's gonna cancel is the reason you cannot plug that damn number in. So that x minus 3, that is gonna cancel. So you focus on the fact that you know eventually you're gonna have to get an x minus 2 on the top that's gonna cancel the x minus. Now what can I do? Can I plug a 3 in?
Yeah.
Hell yeah! So I get that 24 that a lot of you guys got. I love it. Kick ass. So you guys, the 4 just kind of like wandered away, like John Travolta wandered away. What about this guy? We just said what we're gonna use.
Yeah, you conjugate that.
Yeah, which is 3 plus square root of x plus 9.
Then you get 9 minus x plus 9.
You get this.
Yeah.
9 minus the result of this. So I gotta subtract this whole thing. I don't just subtract part of this, I subtract the whole damn thing. So what happens to the 9s?
Cancel out.
Yeah, these cancel. Then what happens to the x's? These cancel. So I got a negative 1. I left my limit out. Is that cool? The 9s cancel?
Hold on.
Wait, how do they cancel? I thought they had to be the same sign.
No. Here, guys, can you, what's that?
-3.
Why? Isn't that negative 8 times 3 over 8? Don't the 8s cancel? Yeah, so,
But for the example that we had like x plus 5 and x minus 5, and at the bottom we also had x minus 5, and we canceled those.
totally, because x minus 5 is exactly the same as x minus 5. X, alright,
Divided the x.
so let me see this. So the 9s cancel, correct?
Yes.
Guys, because they distribute the negative? So I'm left with a negative x on the top. So isn't this negative 1 times x? Isn't that what negative x is? Yes? And on the bottom I get 2x times business. So what factors are the same on the top and the bottom? X's. The negative is just there. It's a factor of negative x is x. So if I have an x on the bottom, they die. And then negative is still there. Nothing killed that negative.
How did the x continue on the numerator? You canceled it out.
I did.
Yeah.
That's why there's a line through it.
Oh, you didn't write anything else. Okay.
So now can I plug a 0 in?
For 18.
From the very beginning, it was because of that stupid x that I'm not allowed to put a 0 in, correct? So I know I eventually want to get an x on the top that will cancel with the x on the bottom. So when I plug a 0 in, what do I get?
1 over 18.
Yeah, 3 plus 3, 6. Wait, what are you guys talking about?
Oh, 12.
12,
Sorry.
yeah.
0 plus.
Oh, 9.
0 plus 9 is 9. Square root of 9 is 3, plus 3 is 6, times 2 is 12. Okay.
-1.
Yes, negative 1 12. I love it. Now everybody's favorite. I really appreciate yes. It's always there. So guys. What's x divided by x? Where did it come from? Sorry, Elena. I'm not trying to be an asshole, but there's an understood one we don't write unless everything else goes away, and then all of a sudden one is like, oh, it's my turn.
But
Right?
when you put, don't you put the 0 in for x?
Well, it canceled.
Oh,
Then I can plug a 0 in safely.
okay.
So here, I can't plug a 3 in until I kill this. Then I can plug a 3 in safely. Right? So that's the whole idea of these algebraic limits. I'm trying to get rid of the problem. Now, somebody had a very creative way to do this. Yeah, start.
I thought if you plug in 0 for x, then how can you multiply it with 2 by
So the x's cancel, right? No. Alright. What's 6 divided by 12? I love you guys. Isn't that because it's 6 over 2 times 6? Yes? Don't these cancel? And you get 1/2? So, That 2 is a factor. It is a separate factor. It is 2 times x times stuff. The x factor is common. They kill each other. The 2 is still there. It's only if I'm adding or subtracting that I worry about how many x's I've got, right? 2x plus 3x is 5x, great. But what is 2x divided by 3x? Do the 2 and the 3 really matter? Because the x's die, that's all I care about. Then I'm left with 2/3. Yeah. But 2x plus 3x, the 2 and 3 really matter because they got to make 5x at the end. Yeah. Yeah.
But what I'm confused about is where the number 9 was, you canceled out the x's. But then you went down, you canceled out x's again. Weren't they
No,
gone?
I'm sorry. I left them in there to be more clear. The 9's canceled, and then on the top I had a negative 1x and a 2x, yeah. Because I had some people confused, I was doing too many things at once. Okay. Alright, guys. Here, this is the last one we'll do, then we'll go on our little tour, and then we'll head out. So, I understand that I teach sometimes differential equations with Math 285, and I have students in the class that have trouble with fractions. We have got to be better. Fractions are shit we made up. We control them. How do I combine 2 fractions? I just give each one what it's missing. So what is this 1/4? What's it missing on the bottom that the first 2 has? It's missing an x. It's not missing a 2. It's got 2 2's. It's got 2's coming out of its ears. All it's missing is an x. What's the first guy missing then to become the second guy? A 2. Now, is somebody concerned about the fact that I did something to the top of this and nothing to the bottom? Well, you shouldn't, because I didn't do shit to the top, right? I multiplied by 1, I multiplied by 1, I didn't do anything, right? That's the whole idea of LCD. So on the top I get 2 minus x over 4x. Okay, somebody with me? Now, one thing you can do that I don't think I saw anybody do to be nice to yourself, because this sucks. This is fracception. This is a fraction inside of a fraction. You're like, okay, Leo, spin the thing. I would do this. 2 minus x over 4x. How do you divide some fraction stuff? Don't you multiply by the reciprocal?
Yeah.
So I can write this like this. Doesn't that look a lot better? Divided by 2x minus 4 is times 1 over 2x minus 4. And then I could factor, let me see if you guys are cool with this. If I factor this guy, can't I take a 2 out of this guy? Yes? Isn't that almost this?
Yeah.
If I just take a negative 1 out of this guy, these will kill each other? Yes. Sorry?
Can you zoom out a little bit?
So, I took a negative 1 out of this, so I changed the signs. If I take a negative 1 out of this, the x is positive, the 2 is negative. That cancels with that. Yes?
I know this is basic math, but you have it as 1 over 2x minus 4. Wouldn't it be 2x minus 4 over 1?
No. This divided by 2x minus 4 is this times the reciprocal of 2x minus 4.
Okay.
Yeah. That's it. How do I divide fractions? I multiply by the reciprocal.
So it would be 1 over something?
Yeah, 1 over 2x minus 4. Yeah. The reciprocal of 2x minus 4 is 1 over 2x minus 4. What's the reciprocal of 7?
1 over
1 over 7. Okay. So now I get negative 1 over 8x. Can I plug a 2 in now?
Yes.
Because right here the problem canceled. So then I get negative 1 over 16. Yay! Alright. So we'll finish this up tomorrow. First thing tomorrow, of course, is the quiz. Very exciting. We're going to do right now, I want everybody, if you want to leave your stuff here, that's fine. I just can't lock the doors. But we're going to walk just very quickly over this way, yeah? Not tomorrow, no. Yeah. Guys, gather your stuff, walk this way very slowly. Wait until I get in front of you. Yes? Okay.